Hello everyone, this presentation is titled When Worlds Collide, and it will be about r4ghidra, which is an integration tool between Radar2 and Ghidra, and I will talk about what this tool does and some of the challenges that arose during development. My name is Buherator, I'm from Hungary, and I'm proud that our demo scene in Hungary is pretty great. I chose the title background from a video by Conspiracy, who are doing great demos, so check them out. I'm a security researcher at Pixie Point Security, also a Ghidra nerd. I do most of the reversing work in this tool, but I'm not affiliated with the spooks. I enjoy weird targets, weird bugs, and weird solutions. And also sometimes create weird tools to solve the constellation of all these things. So today's agenda is, of course, r4ghidra, and I will include a relatively high dose of development content. Sorry about that, but I believe that it's really important to talk about how we could improve in developing our tools and more importantly integrating our tools so different people, different worlds can work together and create and discover amazing things. I take this opportunity also to request feedback from you. There will be surveys with QR codes, and I would really appreciate if you'd fill those forms out. I don't collect any personal data, of course. I'm just really curious about your opinions. And at the end, I prepared some surprise for the whole reverse engineering crowd, which is less connected to R2, but R2 is of course involved, so stay tuned for that. My motivation for working on reverse engineering tools in the first place and integration tools in this particular case is that this sentence that I've heard at a conference a long time ago really echoes back in my mind. It says that I don't use this particular tool, but I buy the license every year just so that IDE has competition. And I believe that this thought is really important because diversity is important. We should have more tools that somehow compete with each other and motivate each other to achieve better results. And I also think that everyone has their preferences, their style, and it would be important to provide the right tools for the right people. So the origins of the r4ghidra project is goes back to 2019 when Pancake started to develop Ghidra R2 Web, which is basically the same project but an old name. And this was basically a compilation of scripts that could connect Radar2 with Ghidra through the R2 Web protocol. And Pancake asked me about a year ago, I guess, if I could help out with the Ghidra side of things, and spending most of my time in Ghidra documentation, I was glad to help out, of course. So, as I said, this thing was based on the R2 Web protocol, which I think is a great feature of Radar2, but it's often overlooked. R2 Web is a really simple HTTP-based protocol where you can create a really simple web server that will basically accept R2 commands and can react with appropriate responses to these commands, and these will be shown in R2's console. And the protocol is great because HTTP is great. Everyone knows HTTP. There is good tooling, good debugging opportunities. It's really easy to understand. It's really easy to extend. So there are lots of opportunities without a whole lot of complexity. And this is what we are looking for when we talk about integration. Of course, by the time I joined this project, there were some pain points that needed to be solved. First of all, the whole code was a single file Java structure, not like proper like classes and everything, because that's how you can script Ghidra using the Java programming language. We also have Python, but it has their own problems. But of course, in case of Java code, having just a single file is not great, because debugging is a pain in the back, and also there were some problems with event handling at Ghidra side. How do we start, restart, stop the HTTP server, etc. We needed to implement lots of new commands. So I dug in and I did a first rewrite where I turned the old project into a proper Ghidra extension, so it was no longer a script, but a proper extension that integrated with the framework. I integrated the development environment with IDEA, which allowed really easy debugging without constantly restarting the whole framework, and the ability to setting breakpoints and watch points and whatnot, which after a certain level of complexity is of course really important. I implemented a small set of commands as a proof of concept. I improved HTTP handling a bit, so we would return like proper error messages and give proper headers, so any client could easily talk to us. And I also implemented a command parser with object-oriented principles in mind. We will get back to this one later, but the bottom line is that it worked, but we didn't really know how to move forward. But first, here's a small demo of the whole thing. So as you can see, you could fire up a headless Ghidra with a small script that read up the project properties. And now that our HTTP server was running, we can connect to it with this R2 web URL syntax from Radar, and use the colon syntax to run remote commands like listing the remote functions and getting a disassembly. So you can see this disassembly is pretty weird, and the compilation is a bit ugly. There is a reason for that. I get back to that in a second. An important piece of information is that this is not just read-only, but read-write. Here we just set a command inside the Ghidra database to the main function, and we will see that this command will persist. So we can not just read data from the remote side, but also write that data to the Ghidra database. Yeah, and here is our little comment. So far so good, right? Okay. So what are the use cases? So one of the reasons that you saw those weird addresses and weird commands previously was that I used a special extension to Ghidra that extended its capabilities to disassemble and decompile code for AS400s, which is a really special architecture in order to demonstrate that with this extension line we can use the loaders and analyzers of Ghidra that tell the framework how to map a series of bytes into memory from a file, for example. And we can also utilize SLAY, which is a special language that abstracts the machine language that we are working with. This is what Ghidra's disassembler and decompiler works with. So once you have a proper SLAY definition of machine code, you instantly get a disassembler and decompiler from Ghidra, which is really great. So this is like a really simple demo, and at this point the whole R2 web thing was really limited because I didn't really know where to go forward, because I didn't really know how the workflow of a standard R2 user works. So I take this opportunity to ask for your feedback about what functionality you would like to see in a tool like this. Here's a QR code that leads you to a form, and I would really appreciate if you could fill that in. I will show this QR code by the end of the presentation too, so you don't have to hurry to take a picture or anything, because the slides will also be published and you will have plenty of time to navigate to this survey. This setup, of course, had some weak points, aside of course, the incompleteness. First of all, adding commands was slow. This was my skill issue, basically, because quite frankly, I don't really get the semantics of the arrangement of R2 commands, so it was really difficult for me to arrange the code logically and provide proper encapsulations. So development in this regard was quite slow. And there is another thing which is more like a design or architecture problem, namely that states are not synchronized. The best illustration of this is that you can basically open totally different programs on R2 side and on Ghidra side, but the R2 web interface would somewhat work still. But the two worlds, like the radar world and Ghidra world, don't really know each other in what state they are in, and this makes work, I would say, a bit cumbersome. So what to do about it? And this is a new era of the new REPL began. It was, of course, Pancake who came to the rescue, who is most familiar with like the command handling and the internal ins and outs of Radar 2. And he basically surprised me after discussing the possible directions and the possible refactor. So he surprised me with a huge commit of like 6,000 lines of new code, which was like a 500% increase in the code size. Which is like a great surprise, especially because we didn't have tests to see if things work as they worked before. So interesting and exciting times came. But when the dust settled, we actually had a working REPL, like a read, eval, print loop in Ghidra, which is a bit different concept from what R2 Web does. I will get back to that in a minute. We also have now a fully transpiled R2 command handler, so every command that was present in Radar was now handled in some way in Ghidra 2. Not everything was implemented, of course, but the command handling logic was there, and that was basically what I was missing. And there were lots of new features implemented, so the capabilities grew significantly. So let's see a demo of that. Here again, here are my weird AS400 programs in Ghidra. And as you can see, the r4ghidra extension is now fully integrated with the GUI. And I can just issue standard radar commands to, in this case, list functions, or seek to different places, and as you can see, the state of the R2 world and the Ghidra world are not synchronized. So if I seek somewhere with radar commands, then it will show up in my Ghidra screen too. This is, of course, again a read-write relationship, so we can just write anything to the database that is now implemented, and it will just show up there. That was the nice part, and it was really impressive to get so much new logic into that extension so fast. But I have to add that there were some alerts going off in my head, especially, so that I believe the root cause of this is that a lots of C-style code was added to the extension, and I don't want to go into flame wars about the necessity of object-oriented paradigm or the drawbacks of it. The thing is, in C, developers follow one set of paradigms, and in Java world we follow different set of paradigms. A prime example of this, for example, error handling. In C code you usually just return some status code that the caller has to check and make decisions based on that. In Java world we usually use exceptions, which can be caught and handled in a different way. You know the drill. But these concepts are, one concept is not better than the other, they're just different. And when we mix them, there can be problems and misunderstanding. The other problem was the lack of encapsulation. So the R2 state and Ghidra state got really intertwined, and there were like really weird bugs coming up, like you flush the toilet and the lights goes out, and that was of course a problem which needed lots of like thinking and following through how the two worlds are entangled, so I could separate them and provide like a proper interface for them to communicate instead of connecting everything with everything. We still have some depth in this regard. For example, as you can see, we still have this HTTP handler code inside the REPL package. So we still have some cleanup to do, but by now I believe the code is maintainable and you can add new features which are requested. And this basically a problem of software engineering, where you no longer do just programming, but you add more programmers and time for the project to evolve. So there are standard issues that we should solve in reverse engineering world also that are present in software engineering world. One of the most important things that you can do when you start up any project actually, but in case of reverse engineering, having proper tests is especially important and especially difficult. It's especially difficult because it's quite hard to replicate all the ways that reverse engineers use their tools. It's also hard to obtain proper samples for target code that will exhibit certain edge properties that you want to test for. But without tests, reverse engineering projects can really easily fall because the complexity is just so large that you cannot keep track of everything manually and try out everything manually. Another thing which I briefly mentioned is that when in Rome, do as the Romans do. So when you are putting code inside Java world, then try to act like Java. When you put code into C world, try act like C. When you're doing things with Rust, then act like Rust does. You don't have any other chance anyway. But I think this is a really good and important principle to keep in mind when you want to start contributing to any software project. But again, in case of reverse engineering tooling, where lots of different languages are in play, lots of different tools are in play, this is especially important to keep in mind. Third, encapsulation and interfaces are really important, especially if you are working with different languages and different paradigms. I think we already discussed it enough, so let's move on. The bottom line is that now we have a nice implementation of state management, so we can keep the REPL and the GUI in sync, which is really nice. We implemented JSON command handling. R2Web broke at radar side for some time, if I remember correctly, but it works again, so that's also good news. And of course, it's natural that all the command handlers are only implemented once, so both the R2 website, which is still present in r4ghidra, and the REPL side that allows you to issue radar commands from inside Ghidra use the same code base for you to manipulate your databases. But still, we have happy little surprise behaviors, and recently I focused or spent most time cleaning up those bits and pieces which didn't quite work well enough together. But still, or again, I will personally need your feedback about what you would like to see in this REPL-like interface, how you would use it, what kind of commands I should implement, and I would be happy to fulfill as many of your wishes as I can. And we already had a couple of, so to say, feature requests. One of these, which I think actually came up multiple times, is that it goes along the lines like, wouldn't it be great if I could transfer symbols between R2 and Ghidra? Which is like a very reasonable thing to ask for, but at this point I was like, hold up. Like, this seems like a quite different problem than the ones that we are currently solving. So if we think things through, then with R2Web we extend R2's features using an external tool, in this case Ghidra. So R2 can see, for example, a particular special case of memory mapping or decompilation, and that's nice. With REPL, we are basically extending Ghidra to act like or work like radar and provide a different user experience for Ghidra's users. And with symbol porting, we should basically connect the APIs of radar and Ghidra in a way that works both ways. And this is, first of all, I think a different problem, and it's a quite hard problem if you think about it deep enough. So, what code should be written? How should this problem be approached? Of course, we could just bang on the keyboards or generate code that transfers knowledge from R2 to Ghidra, but are we really sure that this is the right code to write? Then I remembered this great but not very well-known talk by Travis Goodspeed, some thoughts on literate disassembly and symbol porting, in which he makes the case that when we are working with reverse engineering knowledge bases, so to say, we should stick ourselves to easy to interpret preferably text-based formats that we can keep track of just like a software project. So put it in Git, for example, and track its changes, how our understanding about the code base improved over time. So what we need is a text-based interchange format that would work with all the tools out there. By the way, R2 has been doing this right the whole time. So if you think about the scripting capabilities of R2 and the command line, which is basically the API of R2, this is what's being done. Like having a really simple to understand easily trackable interface for your reversing knowledge. So what I did is to create a JSON-based interchange format, which I like to call reshare, that implements the most important bits of information that I find useful during my reversing work. It is defined with the JSON type definition format, which allows you to generate serializer and deserializer code from it, so you don't have to write that part. What you have to write are tooling around these serializers and deserializers, which are specific to the tool that you want to support, but I'll get to that in a second. I think it's important to show what difference this makes. So instead of creating interchange or symbol porting tools for each tool pair, which can easily explode and maybe summon demons, we can draw like a little sunshine instead, where we only create importers and exporters for this central format. And once you have an importer and exporter for this one format, you can talk to all the tools that have at least export support for it. Some of the principles that I try to follow during this design and development are these. First of all, perfect is the enemy of the good, and I think this is the most important one, because applying some information, some knowledge automatically is always better than applying that same knowledge manually, which is always a tedious task. So even if we won't get perfect matching of the database contents of, I don't know, an IDB, we can still get just enough information for it to be useful for us, and that's the whole point. Another principle I try to follow is to embrace redundancy. When you think about data storage or software in general, redundancy is usually bad, because you have to keep things in sync, and if things get desynchronized, then everything breaks. But in this case, redundancy is basically something that allows error correction and a diverse set of use cases. Like the whole idea behind the reshare really reminds me of these MP3 CDs, where you do a lossy compression of the initial information, which is stored originally in some kind of reverse engineering database. You may lose some of the information, but the most important information is there. And then when you write it on the CD, you have to duplicate information to protect against scratching and physical damage, basically. And this is what we do. So we try to squeeze in as much information as we can into the interchange format, and then the importer can use its error correction logic to get the most out of it. Also, diverse use cases are really important. For example, when you work with different versions of programs and want to port symbols, you won't necessarily need a specific address information, because the address is changed anyway. So that's one use case. And there's of course the other use case when you want to work on the very same program with different tools, where you definitely want to synchronize all the addresses. And these diverse use cases may require different data representation. We try to provide a way for you to be able to embed any combination of these, because the JSON format itself and GTD are really flexible and allow you to just add more information. The third principle is that you can fix it. So I try to keep things simple enough for you to be able to hack on it, you can open up the script, open up the GTD definition, and if you don't like it, you just change it. And most importantly, if you see that something is wrong with the serialized JSON output, then you can just use standard JSON manipulation tools like JQ to fix it, to transform it, to filter it. For example, if you don't want to apply guesses of your reverse engineering partner, then you can just filter out all the data from the JSON that is marked as a guess. So I'm not sure if this function does protocol handling A, then you just won't see it in your database. Currently, we support data types, including function signatures, data and function symbols, which are all typed. I think these are the most important information that you will need in your reverse engineering project. And we have some tools already built around the format. Of course, Ghidra is the most complete. Now, I did a POC for R2, but admittedly, I'm not great at R2 scripting, so I will definitely need some help on that front. And I did some serious work on having a PDB exporter that works purely in Python. Fortunately, PDB parse was there, but I had to fix a bunch of bugs and figure out a bunch of things. But it kind of works now, which is a pretty good thing, as I would say, because you won't have to fire up Windows to parse with Dia. So here's a really short demo again. Here we have our Ghidra project. It's no longer AS400, it's just an exe for the sake of simplicity. We already named this function as report status. We run export, save the JSON to a temporary file. No errors, that's good news. And now we run the R2 exporter that converts this JSON into a series of radar commands. Save it to a file. Give this file to our partner who is on the right side of the screen now. If you take a look at the script file itself, then there will be no surprises. It's just radar commands. And here's a small sample about how the JSON looks like. So these are type definitions, and this is a symbol definition that we see right now. If we open up this netcat sample, we see that we did no analysis on it yet, but if we just source our generated script, we already have a bunch of information about where to look. Of course, Radar can already do this by itself. This is just a small proof of concept about tool interoperability. Some obvious directions for this format is to add tooling for IDA and Binary Ninja, and I'm also thinking that maybe supporting bin export would be nice. Bin export is the base format for bindiff, and we already have exporters for it for multiple tools, so we can basically build on those exporters to give us a JSON-based output instead of a protobuf-based output, which is harder to handle in a way that I would like to see. And of course, we are open to ideas, so please, again, fill in these surveys and give us ideas and preferences and priorities that we should keep in mind. And of course, this is like massive work, like creating all these tools and including all the relevant information inside of the reshare file format, so help is definitely wanted and needed. I will include the GitHub URL in a second. Fortunately, the best news is that we already have a flag, which is this. We do this not because it's easy, but because we thought it would be easy. So thank you very much. Here are the promised URLs. Again, the QR codes for the surveys and some contact information if you want to reach out to me privately. Thank you for your attention.